Any idea how you go with this?
I can't see anything. Like, I just see the same
Oh,
page.
oh, I can see you now. Okay, 1 second. This is really messing up. How about now?
Yeah, that's fine.
Okay.
So when you differentiate 2 to the x, you just get 2 to the x ln 2.
Yeah.
And then 2 to the minus x ln 2.
I think it'd be minus overall.
Okay.
Yeah.
hmm
What is next?
Um, so you have to put x is equal to 2
Yeah.
and find the gradient. So 2.599. That's what I got.
What is ln 2?
0.6931.
So I
Right.
think they want an exact value. So that's 4 ln 2 minus a quarter ln 2.
Yeah.
So what's that going to be? 4
Um,
minus a quarter.
wouldn't it be 4 divided by quarter? Because of log rules.
You could then do a different way. So ln 2 to the 4 minus ln 2 to the quarter. And then it would be divided by.
Okay. That doesn't give you an exact answer, but 4 minus a quarter is 3 3/4. So you could just learn 2 to the power of 3 3/4.
3 3/4 ln 2.
Yeah.
I think that's fine.
And then y equals 3 to the 3/4 ln 2 plus c.
You could do whatever, y minus y1.
Oh, I don't like that one, but okay. Y minus 17/4.
Yeah. And in fact, what is 3 3/4? That's
Three.
15 over 16, is it?
Wouldn't it just be 15/4?
What was it? Sorry, 3 3/4. Yeah, 15 over 4.
Yeah, and then solve. So y is equal to 15/4x.
Hang on. Multiply everything by 4 first,
Um,
instead of at the end.
4y minus 17 is equal to 15x minus 2. So 4y is equal to 15x minus 30 plus 17, which is minus 13.
Minus 15x minus 13. Or 15x minus 4y plus 13.
Yeah.
Let's take a look.
Okay.
17. Do they do something? They have 15. They have 17 minus. 15 over 4 ln 2. Did we forget the ln 2? Yeah, we did. We just forgot that.
Okay.
So ln 2. Okay. Okay. Any questions there?
Yeah, it's not that bad.
Okay. So that one should be 15 ln 2. It's x minus 4y. 13 ln 2. Yes. Is this worth doing, or is it the same thing? Equation of a tangent.
So e to the 2x is just 2e to the 2x. You differentiate. And then minus 1 over x. Minus 2. So just 2.
I think this will just, hang on. So what are you differentiating?
E to the 2x minus ln x. So it's 2e to the 2x minus 1 over x.
I'm not getting it. Let's see. So it'll just be 2e squared minus 1, I think.
It wouldn't be 2e to the 2x minus 1 over x. How do you get?
Sorry. I'm looking at this one.
Oh, okay.
Sorry. I was looking at the wrong one. So this one, dy by dx, 2e to the 2x minus 1 over x. Is that what you were saying?
Yeah.
Sorry, I was looking at the wrong one.
E to the 2x.
Yeah.
And then you substitute x as 1. So that would just be 2e squared minus 1.
Mm-hmm.
And then you could do points of form, I guess, but you don't know the y coordinate. You could find it.
So we have the gradient at that point.
Yeah. So you just have to find the plus c.
Yeah. If you prefer that way.
Yeah. So y is e squared.
Mm-hmm.
So that would just be c is equal to e squared minus 2e squared minus 1.
Y. So the y coordinate, will that be ln 1?
Yeah, but isn't ln 1 0?
Okay. And so you just did it all in one go, was it?
Yeah.
That's times by x, which is 1?
Yeah.
Okay.
So then it would just be y equals e squared minus 2e squared plus 1. The e squared minus 2e squared is minus e squared. So
yeah.
that's 1.
All right, that's 1 minus e squared.
Yeah.
So we have, so that's c. And so y equals?
2e squared minus 1 x minus e squared plus 1.
Plus 1. That's it. Great. Any questions there?
No.
Is this the same stuff? Or is it worth doing?
It's just differentiating.
Yep. Let's see. e to the x2 ln. What is the derivative of? Yeah, go on. What is this?
So e to the minus x is just minus e to the minus x. 2 ln x cubed. Well, that's... could you do 2 ln x cubed is equal to 6 ln x, or is that wrong?
Yeah, 6 ln x.
Okay, that's correct. So that would just be 6 over x, right?
Yeah.
Yeah.
And I think you can leave it like that. Yep, great. So it's a normal. It's a little different, but I think it's the same idea. It's up to you if we do it or not.
I don't mind.
Let's just see what else there is.
Tangent.
It's tangent. It's very similar. Just tell me if you see something that you think is really worth it. Steps. So you have to factorize this thing. That seems straightforward. They just
Yeah, I think so.
They just factorized it at the end. This is the proving of that one.
Oh.
Which we did. Let's see. E to the 2x.
I know this. I think.
Yeah, just derivative and then sub that in. So this is trig. Is this in the right place? Yeah, it's just trig. It's no. Point P lies in this equation. The x coordinate is 1. Equation of a normal at point P. Oops. Let me just see. So that's the very last one. Is it worth doing, or you think you're okay with it?
I don't know how to differentiate that.
So it just means 2 times that.
Yeah. 3 to the 4x would be 4 times 3 to the 4x times ln 3.
Times 3 to 4x times ln 3. And then I think it'll be the whole thing times 2.
Yeah. You wrote ln x, but...
Sorry?
You wrote ln x instead of...
1 over x, is it?
No, it's ln 3.
Why am I... ln 3, yes.
Yeah, that's it.
Okay.
So ln 3 times 3 to the 4x. I don't really know how you simplify that.
When you have an x coordinate of 1, so an x is 1.
E to the 4 times 8 times ln 3.
Yes. I forgot. Hang on. Ln 3. Yep. So that's going to be 8. 3 to the power of 4.
3 to the power of 4 is...
81. And so that's 81 times 8 ln 3.
648 ln 3.
643.
48.
Ln 3.
So
the x coordinate.
So for normal, it would be the reciprocal. So it'd be 1 over 648 ln 3. Yeah. And then you just do y equals mx plus c and fine.
And what is y?
81 times 2, which is 162.
62. So y minus 162 is equal to, and it's a negative reciprocal,
Easy
isn't
to
it?
do it in mx plus c because it says it wants it in that form.
True.
I really don't like this.
X minus 1. You could just go from there.
Yeah.
Yep.
How to solve that?
Hang on. So y equals minus 1 over 648 ln 3x. Then it'll be 162 plus that. And so plus 162 ln 3 quality's kind of weird.
Yeah.
Over ln 3, is that right? Hang on, so plus 1 or something. Over ln 3. It's something like that. In its exact form. Okay, so they didn't add those two fractions. They just kept them separate. That's cheating. But anyway, yeah, so what do you give yourself for those?
Let's do it.
Yeah, how was that for you, Amogha?
Good.
Anything in particular you want to do next time?
I can send it. It's probably for me to do. So.
Okay. Any questions for me in general?
No.
All right, well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.